Hello friends, welcome to GMD classes. So in these sessions we will discuss about maxima and minima. How can we find the maximum value and minimum value of any function? Suppose f of xy. This is the function having variables x and y, two variables. Okay, this is two variable functions. And if suppose z is nothing but f of x, this is a single variable function. Okay, so we will see how can we find maxima and minima of two different functions. One is two variables and another is single variable. So first we will see about single variable functions. So any functions given, suppose f of x is nothing but x square plus 2x minus 1. Okay, such types of functions are given. So we want to find the maximum value. What is the maximum value and minimum value of these functions? So what is the method to find the maxima and minima of the given function? So we will find maxima and minima of any functions by the help of derivative. So with the application of derivatives, we are able to find any function's maximum and the minimum value. Suppose any given functions, such types of functions are there. This is the f of x. We will see in this graph this value starting from the 0 and increasing, and then after some points, that is this value, suppose x naught, then function again start decreasing and then comes to 0. So this value is maximum value for the given function. Okay, after you can go whether right side and left side, the value will decrease. So this is the maximum value. So how can we find this maximum value? So see here, at the maximum value, you see, when you find the slope of this curve, you will see slopes becomes 0 or parallel to the x-axis. So when we find derivative, nothing was f, the differentiate function as, this is nothing but the slope of the functions. Okay, so this is the slope of functions. So we are equating that slope is 0. Let's see, at the maximum point the slope becomes 0. So this is the method through which we can find the value of the maximum. So see, here this is at x equal to x naught, we assume. So this, at this points, the value gain maximum value. So this is called maxima, and we find the function's value at x equal to x naught, we will get the maximum value of that functions. Okay, so in the case of minima, if any function, suppose see here, in the case of minima also, slopes becomes 0 or parallel to the x-axis. So slope is nothing but any function df by dx. We are equating this 0. Okay, so this is the method through which we can find. So see, if you want to find the maximum value of these functions, how can and what is the method? So condition, see what is the condition. First, find derivative of the functions, derivative of the given function. Okay, and equate it to 0, so that we can find the stationary points, and then find second condition. After equating 0, you can find a stationary point. So in this case, x naught is the stationary points, this is the stationary points. Okay, so find the stationary points and check double differentiation. Again find f double x. Okay, and put the value at, put a stationary value in double different f double dash x and check the sign. Check sign. Okay, if sign is positive, suppose f double dash x, we have a stationary points x naught. Okay, if less than 0, then this is maxima. This is maxima. And if f double dash x naught greater than 0, this will give minima. Okay, so this is the conditions we can apply in any types of functions, and we are able to find the given function is whether at the stationary point minima or maximum, that is posing maximum value or minimum value. So maximum minima is the stationary value, stationary points, and at that points if you find the value of the function, you will get the maximum value or minimum value. So see here, these questions I will try. Suppose differentiates f dash x. Okay, so we will see twice of x plus 2. Equate it equal to 0. You will see second condition equal to 0. So twice of x plus 2 is equal to 0. That means x is equal to minus 1. So a stationary point is a stationary point. I will get minus 1. Okay. Now we have to differentiate again. So again differentiate f double dash x is nothing but 2. Okay, so here see, if we put this is independent of x, doesn't depends on x value, so this is greater than 0, so this will give you minimum value. So minus 1 is minima. What is a minima? And if you find the given value of the function at this points, you will get the minimum value. Okay, so this function is a minimum functions. You can find only the minimum value, you cannot find the maximum value. Okay, so this is for the single variable functions. If you find the if you try to find, you have to find for the double variation, that is two variable. So what is the method for the two variables? So see, same for, but some little bit different here. First I will tell you the basic, then I will give you some shortcuts so that you can easily solve maxima and minima value. So first see the process wise. Okay, so for the two variable functions, any function, suppose z is f of x and y. Suppose this is two variable functions, so we are assuming any two variable function. Suppose given here 3x square y plus 2yx plus 3y minus 2x. Okay, this is the functions given, and we have to find the maxima and minima. Okay, so how? Let's see. So for two types of variable, that is containing two variables x and y. So first find p, nothing but d of z by dx, q dz by dy, r d2z by dx square, s d2z by dx dy, and t is nothing but d2z by dy square. So we are differentiating z with respect to x is p, q is nothing but the differentiating z with respect to y, r is double differentiating. If you differentiate p with respect to x again, you will see r. If you differentiate p with respect to y, you will see s. And if you differentiate z with respect to y again, that is you can differentiate q again with respect to y, you will get the t. So you can also see here in this case, and apply for the stand to find the stationary point here. To find the stationary point, okay, I will see again. To find the a stationary point, a stationary point. Okay, so this can be a stationary. For what is the condition? Apply p is equal to 0, q is equal to 0. Okay, first condition, and this is the second condition. P is equal to 0 and q is equal to 0. You can find a stationary point through these equations. Okay, then apply rt minus s square. Okay, this find rt minus s square, and then second condition, then third, in the third conditions you apply rt minus s square greater than 0. If rt minus s square greater than 0, less than 0, or equal to 0, what happened? See, when rt minus s square greater than 0, then maxima and minima occur. Okay, so in this condition it depends on maxima and minima happening. Okay, so when maxima and minima occur, maxima and minima occurring when it depends on the r value. Okay, if r is less than 0, then maxima. If r is greater than 0, this will give you minimum. Okay, this, for this value you will get the saddle points. You will get saddle points, that is the function doesn't attain, it doesn't gain extreme value. Okay, so extreme value doesn't get. In this condition, when rt minus s square is equal to 0, this function at this condition undecided. This is the undecided conditions. We are not able in a condition, we are not in a condition to find whether, say, you can say whether the function attain maxima or minima, maybe or may not be. Okay, the function may be maxima or may not be maxima. So for this condition, we simply, you can say, undecided condition. What is undecided condition? See, so these are the conditions. So I will solve some questions so that you can learn easily. Okay, so let's see one examples. I am taking one examples. So types of questions. See one question here, simple. I'm taking for single variables. Okay, 6x square minus 6x minus 36. Okay, I will see here. So find the maximum and minimum value. So to find the maximum and minimum value, we have to find first maxima and minimum, that is the stationary points. So for the stationary points, we differentiate first. Let's assume we differentiating f dash x 12x minus 6 is equal to 0. Then x is nothing but 1 by 2. See, then again double differentiates. We will see here 12. It doesn't depends on the x, it is greater than 0, so this is minima. What is it? This is minima. So if you put the value x equal to 1 by 2 in the given functions, you will get the minima value. So see, so what is the minima value? So f of 1 by 2 is nothing but 6 into 1 by 4 minus 6 into 1 by 2 minus 36. Solve it. 1.5 minus 3 minus 36. So you can solve 1.5 minus 39. So nothing but 0.5, 37.5 minus, you will get the answers. So this is the minimum value. So the functions is gaining minimum value. Okay, Now I am supposing two variable questions. Okay, I am supposing here two variables. So see, suppose z is nothing but f of xy. Okay, so f of xy, see, twice of x cube minus 24x plus 107. Okay, in 1 and 3. Okay, so see, range is given here fixed. We have to take a stationary value in this range 1 to 3. We can take 1 and 3. So this is global maxima and minima conditions. So I will first discuss global maxima minima conditions. So global maxima and minima, what is say? In this condition, you see range is given, that is you have given a to b. Okay, you have to find the functions maxima and minima. So for the global maxima you have to find f of a, f of b, and then the local maxima value you have to find f of local stationary points and in local maxima and minima. After all, you have finding, after all you compare which one is greater. So greater one is called the maxima and the minimum, that the least one is called the minimum. Okay, so here same conditions, range is given here 1 and 3. So we first find the stationary points. Okay, this function is even single variable functions. Okay, so we are taking only single variable functions. So see here, so how can we solve? First find the stationary point. So for the stationary points we have to differentiate. So f dash x is nothing but 6x square minus 24. Okay, equate 0. This implies x square minus 4 is equal to 0. This means x is equal to plus minus 2. So we are getting x equal to plus 2 and minus 2, but see minus 2 is not lie in this range, so we are neglecting minus 2. Okay, minus 2 is neglected, so we are getting only stationary points 2. So this is the problem of global maxima and minima. So you can see we have to find function f of 1, f of 2 and f of 3. So we have 3 stationary points. We have find one stationary point, but we will also include 1 and 3 and comparing these 3 and find the maximum and minimum value. So see, when you find f of 1, see, directly put the value in this equations. You will see here f of 1 is nothing twice of into 1 minus 24 plus 107. We will see 2, that means 107 minus 22. So this implies 5 and 2 8, so 85. Then f of 2 nothing but 2 into 8 minus 2 into 24 plus 107. You will see 16 minus 48 plus 107. So how can you solve? This is 3 1 2 123 minus 48, so 5 7. This is 75. So f of 3 you will see twice into 27 minus 72 plus 107. Okay, so when you solve you will get 89. So compare this, f of 1 is 85, f of 2 is 75 and f of 3 is 89. So this value is maximum. So for these functions f of 3 is, that is maxima. maxima occur at 3. A maximum value, what? Maximum value is 89, and the minima is occurring at, you can see, 2. So x is equal to 2 and value is what? 75. This is the minimum value. So in this way you can solve any given function maxima and minima. So you have the knowledge of differentiability, that is derivatives. Okay, so now we are assuming another questions, that is two variable types. Okay, see here I am taking questions. What is see? Let's question is two variable f of x and y. Okay, x square plus y square plus 6x plus 10. So you have to find maxima and minima. Range is not given. Okay, so how can find? This is a two variable functions. First, two variable function. Okay, so we have to find p, q, r, s and t. Okay, so p, q, r, s. First find p. P is nothing but df by dx. So differentiate the given function with respect to x. So you will get twice of x plus 6. Q is what? Differentiating with respect to y, twice of y. And r is nothing but differentiating p with respect to x, that is 2. S is nothing but differentiating p with respect to y, this will give you 0. And t is nothing but differentiating function q with respect to y, you will get 2. Okay, so for the stationary points, you will put p is equal to 0 and q is equal to 0. So put here twice of x plus 6 equal to 0 and again 2y is equal to 0. You will get y is equal to 0 and x is equal to minus 3. So you get the stationary points. The stationary point is what? Minus 3 and 0. This is the stationary points, and at these points we have to find the value of the function and we have to check this given stationary point, not given, this is the calculating stationary point, is whether maxima or minima. So put the conditions rt minus s square. So first find rt minus s square. So rt is nothing but 2 and t is nothing but 2, minus s square is 0, that is 4. So this is not is equal to 0, but this is greater than 0. You can say this is greater than 0 and r is greater than 0. R is what? R is equal to 2, that is greater than 0. So you will see that this function is minima. So this function is minima. So what is the minimum value? Put the value minus 3 and y in this given functions, you will get the minimum value. So putting f of minus 3 and y, you will get 9, 0, this is the minus 18 and this is plus 10. So you will see this will give you 1. So f of minus 3 and 0. So minimum value is 1 and this is the minima. So minima point is stationary points minus 3, this is the minima. So in this way you can solve maxima and minima. Again, another types of questions are generally asked which are given some stress way, that is some conditions are given. Okay, these types of functions, that is Lagrange method, a Lagrange function. Okay, Lagrange functions what? You have given f of x, y, z. Okay, and you also phi is nothing but x, y, z. Condition is given. Something condition given. Okay, this is equal to c any constants, and you have to find the maxima and minima of the functions. So one condition is given. Suppose I am taking one questions. Okay, see, x plus, you have to find the maxima and minima x plus y plus z. This is the function f of f. I mean, assuming here, see, f of x, y, z is given here, x plus y plus z. Okay, and one, this is given here, x, y, z is nothing, 1 by x plus 1 by y plus 1 by z is equal to 1. So condition is given, and this function we have to find the maximum and minimum value of these functions. How can we find such type of, these types of function is called Lagrange function, and we can write these functions here. This is nothing but capital F denoted by x, y and z. This is f of x, x, y, z plus lambda times of phi of x, y and z. We can write this function in this way, and this is the form of Lagrange functions. Okay, so now we have to find the maximum and minimum. Same way, this is the three variable functions, so we can find simply df by dz, dx, df by dy and df by dz, and equate with 0 and find the stationary point, and then put the value of the stationary point in this function. You will get the maxima and minima. So how can we solve? See here, so if we differentiate, you will df by dx nothing but only one, that is x, and we can see, right? So first try to find such types. See here in the differential form, how can we write? So df by dx, you can see x plus y plus z, okay, plus lambda times 1 by x plus 1 by y plus 1 by z, given is minus 1. This is the function. Okay, this becomes function f. Suppose now we have find f of x, that is df by dx with respect to differentiating f with respect to x, we can write here df by dx. Okay, so we will get 1 plus, this is the minus lambda times of minus 1 by x square. Okay, again we differentiate df by dy, you will get 1 plus lambda times of minus 1 by y square, and again you will differentiate df by dz, you will get 1 plus lambda times of minus 1 by z square. Okay, so you will get an equate equal to 0. After differentiating, you have to equate with 0 so that you can find the stationary value. Okay, so now I am removing these portions. Okay, so now when I will put f dash is equal to 0, you will get, first you put 1 plus lambda by minus 1 by x square is equal to 0. So you will get the value of x. What is it? So you can see here, when you put equate with 0, you can get minus lambda by x square is nothing but minus 1, 1 minus minus cancel out, so lambda is equal to x square. Okay, so x is nothing, this implies x is nothing but under root lambda. Similarly, you will get y is equal to under root lambda and z is equal to under root lambda. So you know the condition is given 1 by x plus 1 by y. So put equation 1 by x, that is 1 by x plus 1 by y plus 1 by z is equal to 1. When you put the value, you will get 1 by root lambda plus 1 by root lambda plus 1 by root lambda becomes 1. So you will get, after solving, you will get the value of lambda. So 3 by root lambda is equal to 1. So lambda is nothing but 9. You will get the value lambda is equal to 9. When you get the lambda is equal to 9, you can find the function f of x. So f of x is what? So you will get x is nothing but 3, y is nothing but 3, and z is nothing but 3. This value you can find. Again you can find minus 3 or minus y. X square is equal to, you can see here, x square is equal to lambda. X is nothing plus minus root lambda, plus minus root lambda. So you will see two values. So two stationary points you give. First is 3, 3, 3, and another is minus 3, and minus 3. Okay, these two stationary points you will put in the functions, you will get the maximum value. So function is what? See, function is f of x, y, z is nothing, x plus y plus z. This is the function given function is this. So you can put the stationary points. First 3, 3, 3, you will get 9, and another, when you put these stationary points, you will get minus 9. So this is the maximum value and this is minimum value. Okay, so this point is minima and this point is maxima. So I will get two stationary points. Stationary points are, see, one is 3, 3, 3, and another is minus 3, and minus 3. This is maxima and this is minima. So maximum value you will get 9, minimum value you will get minus 9. So these are the types of functions which are generally asked in the maxima and minima. So you can find maxima and minimum of any function. So I hope you are able to understand, and I request you to solve lots of problems so that you can gain more concepts. Thank you for watching my channel, watching my videos. Please subscribe my channel and like my videos and share among your friends. Okay, thank you.